How's everyone doing? Good, good. Thank you for coming to the Dataflows session today. My name is Mohammed Ali, and I'm the Power BI Dataflows PM. Today we have a huge speaker lineup, and so I'm just going to go straight into it as we've got a lot of content to share with you guys today. And so the agenda starts off with me giving you a very quick, brief introduction to how Dataflows will work, and just kind of get everyone up to speed on what Dataflows is. Then I'll hand over to Christian, who's going to go through how you scale Dataflows and get the most out of Dataflows. And then I'm going to hand it over to Bogdan, who's going to go through AI and Dataflows and actually talk about how the actual engine works with the AI workload. And then I am joined with Delia, who's going to go through the best practices with me for Power BI Dataflows. And then I'm going to close off with a favorite section of mine around customer feedback and what we've done to address the feedback in the last 6 months. And then I'll close it off with the roadmap. So what you really want to get out of this session today is you'll get hopefully a good idea of when you should be using Dataflows, and hopefully you'll start migrating yourselves to use Dataflows. And hopefully you'll walk away with having a much deeper understanding on how the architecture of Dataflows works and why you should be using Dataflows. And so I'm going to just spend 2 minutes. Hopefully you guys are very familiar with Dataflows, which is why you're here. But I'm going to quickly go through what are Dataflows. So typically when you're working with ETL, trying to get your data in the right shape or form, a lot of the time is just spent doing data prep or data preparation. And so combining the data from different sources, making your Excel sheets and combining them with your SQL Server data is a very hard problem, and is the reason why we actually invented Dataflows. And so if I move to the next slide, I actually show you how you actually use Dataflows. So I made this animation earlier today. And so when you go into Dataflows inside Power BI, you can actually just go for a long list of connectors that we have available. You can just select one of the data sources, click Next, and very easily select the data that's available at the source. And as you see, as I go through this, as I go through the experience, I can quickly right-click on a column and manipulate the column. So in this case, I'm showing you all the functions that are available. I do a very quick date cleaning fix. And then I also rename the column to show you how quickly and easy it is to get the data in the right shape or form. And so I'm doing this all within a browser. You could be using any machine. You could be using it anywhere, anytime. And then once you do that, you can then save, and then you move on to preparing your reports. Dataflows are quite like Excel, so you can actually create building blocks on top of Dataflows. So you can create Dataflows on top of Dataflows. So you can bring in your source data from your source systems and then merge it in a separate data flow. And it works just like creating building blocks or how formulas work in Excel. And finally, Dataflows is built on top of Azure Data Lake Gen 2. And the reason why we believe is so much in this vision is that every other Azure service will use the same data substrate inside Dataflows. And so every other Azure service can access that data. The data is completely transparent. You can see what the data is and then use other Azure services to quickly harness the power of the data. With that, I hand over to Christian, who's going to go through the enhanced compute engine for Dataflows.
Thank you for the wonderful introduction, Mo. And I'm really excited to be here and talk to you about Dataflows and in particular about scale and performance. So I'm going to start by looking at some challenges that people have today with data preparation in Power BI. And you can have data preparation if you go to Power BI Desktop and you use Power Query to get a ETL pipeline inside the data set. And behind the scene, we host an engine, an M engine, we call it. We host an engine that does all the calculations and transformation. And while this engine is very good at integrating with a large number of data sources, as you saw from all, it's 70+ connectors, and you can add even your own custom connectors, it's not as good as, let's say, SQL to join, sort, combine, push down aggregates as SQL is, because it's good at other things. Therefore, the impact is that when you do this, you get all the power of Power Query Online, you get Power Query, you get the connectors, you get everything, but the memory footprint that you will have for large volumes of data can be prohibitive in some scenarios, as well as the refresh times are going to take a lot of time. So what we've done we created Dataflows engine that isolates this in a separate construction flow. And therefore, in the data set, you just get the data out of the data flow. One advantage is that we created a SQL, we put a SQL engine with a columnar store on top of the data flow, so each entity gets cached. So I have a picture that shows this. This is the data flow engine. This is the traditional one that is now in GA, it's general availability. And it shows in green, these are the data sources that we have. We get the data, and there's a little, it's the same M engine that is hosted inside the data sets. And it puts the data in ADLS storage. It's already much better than the data set scenario. The reason is that each entity is now cached on disk. And when you do a transform, let's say you want to join two entities together, now you don't need to do all the transformations that led to those entities before. But we went a bit farther, and we added SQL, a SQL engine. So when you buy Power BI Premium, inside the data flow workload, there's a SQL engine put inside. And this SQL engine caches all the entities inside the data flow. So if this data flow is like in the picture there, if you see there I'm showing on the right, if you see the two entities on the bottom that are getting data from a relational data source, this is the result of that operation. And now we perform a join. So already performing this join using data flows, I explained to you, is faster than doing the same type of transformations in data set. But what we've done, we added SQL caches of those entities. So we have a SQL Server Enterprise grade engine with columnar store, with columnar index. Oops, I got to the wrong thing. And, okay. All right, so we're here. When we perform this join, now it's going to push the join operation down to the SQL engine that we have there. And the advantage is that it takes advantage of the SQL joins that's not of the SQL operations that's not available inside the, if you do this inside the data set. And it's also not available if you do without the enhanced data flow compute engine. The enhanced data flow compute engine is now in public preview and is going to GA soon in the next couple of months. Then we run some results, and we actually try to compare this with the refresh of data sets or the refresh of the original data flows. And what we tried on TPCH, and we noticed that actually we got about more than one order of magnitude of performance improvement, about 25x performance improvement with that. So this is very good, and it helps us tremendously, and that's a great first step. So why did we do this? So what's the next step after this? So we said, wow, it would be great if we have the SQL engine. If we don't have to even get the data out of the data flows, you can, as the queries come, you can send the queries to SQL directly. So we have DirectQuery, which is now in almost getting to public preview. It's going to, again, being a couple of months in public preview. So before I'm getting into a demo, let me show you what DirectQuery is, unless you already know. So I'm going very fast. So DirectQuery, as you have the reports and dashboards sitting on top of the service and ultimately on top of a data source, we have two ways of handling the data. Either we get it ahead of time inside the analysis services that fuels Power BI. And that's a very, very fast engine. And then all the queries would go to that cache. So that's very good for cache speeds, but it has two problems. One problem is that there is a latency, the time to suck all of the data from the data source. And the other problem is that there is staleness. So once the data lands in that cache, it will keep getting more and more stale as the data gets refreshed in the original data source. The other way is to actually don't get any data in the data set, and as the query comes, rewrite the query in the underlying data source language, and basically you eliminate all this latency and staleness. The disadvantage is that some data sources can be slow, so your reports might be rendered slower. But the engine that we have inside, it's actually the SQL engine that we have inside the Dataflow engine is based on the same technology that Analysis Services has, because it has the columnar store. So it's going to perform reasonably within the same limits. So I'm going to show here that if this is a data flow, of course, you cannot push predicates down or aggregation functions because you don't have a SQL engine. But if you have a SQL engine, you would do that. So I have here very quickly, I have here a report that I prepared. So I would like to see kind of what's the performance of handling data flows without getting the data inside the report. So I'm going to drag here. I have a calculation that shows the total rows. Oh. What do I need to do?
You need to end the slide.
Oh, I see. Oh, because it's in presentation.
Yeah. Okay. Just exit out, and it should work.
Okay. So I dragged here a total rows count, and I'm going to set it as a card so we see it, and we want to see without this formatting, so I'm going to put display units none. So actually this looks like a phone number. It's not, phone number is the number of rows, it's over 100 million rows. So it's actually, the performance of interaction between them is reasonable. As you see, it's like about 1 second to operate on such a volume of data on DirectQuery. So this is what we're going to launch in the next couple of months. But then the question was, what's next? What's after this? So I want to show you looking forward where we're going. So what we want to achieve is actually real time. So from the moment the data gets originated up to the moment it shows into your report to be like 0 time. So I'm going to show you a click-through of what we think is going to be. And imagine when you build a data flow, you can go and select one of the data sources that would be a stream. So if you have a Kafka stream or any other type of stream that comes from Azure Stream Analytics or from IoT devices, you'd be able to select, still have the same Power Query experience that you have in data flows, even do transforms on top of it. And then once you save it, you'll be able to have reports that go and update themselves as the data comes. So 0 time originating from that. So in terms of the architecture, what we think it will be is that as data gets originated, we'll put it directly into the cache and into the SQL cache and into the ADLS Gen 2 store. And then under a real-time monitoring service is going to fuel the Power BI data set that's it will be in DirectQuery mode that sits on top of that sits at the basis of the report. So this has no timeline, no anything. I'm not responsible for timeline. This guy, Bogdan, is the director of engineering. He will deliver it. And with this, actually, I want to introduce Bogdan, who is going to tell you about AI in data flows.
Thank you for the very warm introduction. So as you have seen so far, data flows look and feel just like Power Query. The major difference is that instead of running on your laptop or your desktop, it's running on the cloud. And because we have a pretty big cloud in Microsoft, we decided to take some of the investments that our friends in Azure have made in artificial intelligence and make them very easily available in data flows. So some of you may be familiar with this, but I will start with a very brief demo of the AI capabilities we added to the data flow, after which I'll discuss about the implementation details. I'll switch out of this and go here. So As I said, it looks and feels just like Power Query, but in a data flow, you can go and invoke AI insights. And by invoking AI insights, you get access to a set of machine learning capabilities that either we make available for you or your organization makes available for you. For instance, you may have heard about cognitive services. You can use cognitive services if you have a license and if you are willing to write the fragments of REST API invocations that are necessary to push your data to a cognitive service and get the results back. But by using Power BI Premium, you have access to those cognitive services directly here. And the cognitive services appear just as functions for dealing with your unstructured data. And we support things like image tagging, key phrase extraction, language detection, or sentiment analysis. In fact, I'm going to apply sentiment analysis right now on a set of reviews that I have. So when we invoke a cognitive service, we are going to take each piece of text that is passed as an argument. We are going to run it through the cognitive service developed by Azure ML. And then we are going to produce a new column in your data flow, which gives you an idea of the sentiment in that review, in this case. If the score for the sentiment is a number, if that number is closer to 1, then the sentiment is mostly positive. While if that number is closer to 0, like here, it's a negative sentiment. And if you go just a bit here, we see that the review text is talking about worst ever something. So it kind of justifies my statement. Now, the other thing that we do is that we take a look, because again, in the Power BI service, we know your credentials, we know who you are. So we take a look across the Azure ML workspace and you see how many machine learning models are made available by data scientists to you, data analysts. And then we take a look at the signature of those Azure ML models, and then we expose them as functions that you can invoke in your data flow. So you see here that I have a set of machine learning models that were exposed to me by our organization. I can pick either of them, pass a column as an argument, and it's going to look and feel just like any other function in Power Query. And last but not least, we have the ability to create new machine learning models inside data flows. We leverage technology from Azure, which is called Automated ML. And using that technology, I can go here and say that I want to add a new machine learning model. We have a wizard-like experience that allows me to select what I'm trying to predict. In this case, I'm trying to predict whether some water pumps will or not become dysfunctional over the next, let's say, 60 days. We do a bit of magic to figure out what data inside your data flow is relevant for your prediction. We give you a few recommendations on how to structure your prediction. For instance, in this case, I want to find things that will be non-functional. And again, after going through this wizard, I can launch the training process, which is going to find automatically the best machine learning model for our scenario. And then once I create the machine learning model, I can invoke the machine learning model in the same or different data flow. And applying predictions from a machine learning model is about as easy as all the other functions that I've shown you. I'm not going to finish this because it takes a few minutes, but I'll just show you the results. Every time a machine learning model is created, you get a very detailed statistical report, which is going to, hopefully in a few seconds, show you the accuracy of your model. Again, even if this doesn't work right now, I'm happy to discuss afterwards about the content of this model. The model can be applied to new entities in your data flow. And this way, every time you ingest new data, we have the ability to apply predictions and enrich your data. And that allows you to do some fancier reports like this, which are telling me that this particular water pump in Tanzania, in Dar es Salaam, in the capital of Tanzania, has a very high likelihood of failure because all these particular features of that water pump. I do not want to go very much into the detail of automated ML in data flows. There were different sessions for this, and we'll be happy to take questions. But I wanted to show the capabilities. And now back to PowerPoint, I'd like to tell you a bit how these capabilities are implemented and what happens with your data when you are invoking AI from data flows. So first, let's talk about the Azure ML invocations. When you are applying an Azure ML model, you are talking about an object, the Azure ML model, that has been created by a data scientist inside your organization. And presumably that data scientist gave you access to that model. In order to apply that model, we have to take your data from the data flow storage and push it to the Azure ML web service, where we run the respective model, get the results back, and then we append the predictions as a new column to your data flow. Regardless of whether you are in Power BI Pro or in Power BI Premium, regardless of whether you are using a dedicated or a shared capacity, the same thing happens. Your data will leave your capacity, go to the Azure ML space, get analyzed, and the results are getting pushed back. Sorry. Oh, let's do this. But if you are using premium, we have this concept of workloads. We have different analytical workloads that are running on your premium capacity. The most famous of them is the analysis services workload, which supports all the queries. But you also have something called the machine learning workload. That allows you to do some extra capabilities that are not available on shared. So inside this machine learning workload, we host the cognitive services that are produced by Azure ML. So if you are to apply something like sentiment analysis, key phrase extraction, or anything else from the cognitive package, your data will not leave the capacity. So that means everything is going to happen in place. Furthermore, you don't even have to pay for an Azure license to use cognitive services because you are already paying for Power BI Premium. And these features are packaged in the Power BI Premium offer. Things are a bit more interesting for automated ML. Automated ML is a pretty fantastic technology from our ML group. They are capable to tell you which is the best model and the best combination of model parameters in order to analyze your data and to build the prediction model for your data. Now, this is a tough problem. It takes a PhD to learn very well one algorithm and the sets of parameters for that algorithm. So we are talking about the combined work of really many PhDs that created a system which is able to tell us which is the best algorithm to run next. All of the algorithms are actually hosted onside your premium capacity, which is to say that your data, again, is not leaving your capacity. You don't need to get any kind of Azure subscription. Data is being moved from the storage, which is the data flow, towards the machine learning algorithms that are hosted in the AI workload. We try to run a couple of known algorithms. We collect the accuracy of the models produced by those algorithms, and we send that accuracy information to the Azure ML Web Service, which, looking at that accuracy, is going to tell us next you should run a decision tree, or next you should run a neural network. And we keep iterating on this process until either the accuracy of your model converges, it doesn't increase significantly, or the time that you allotted for this experiment has expired. So long story short, because this is a complicated story, regardless what your data is, we are taking your data from your business area through Dataflows. We are going to automatically select the model that best formulates your data problem. Then we are going to start this chatty conversation with the Azure ML service and figure out how to tune the hyperparameters of that model, in the end getting the model of the best accuracy for your data. Now, once you have that model, as new data enters the Dataflow system, is going to be used to retrain the model or to be scored by your model. And this is it about the AI, and I'm going to hand it over back to Mo. Thank you.
Awesome. Let me go back. So this is my favorite part of the session, where we go through best practices for Dataflows. And today, I'm actually joined by Deli, who's going to actually help us go through these best practices today.
Hi, Mo. Thanks for having me here. My name is Elia Fernandez. I work at Avanath, and I'm one of the early adopters and big team of Power BI Dataflows. So just before we start with the best practices, I just want to mention that the following are guidelines, and there may be reasons that you must deviate from using each one of them.
Awesome. So we'll go through the best practices. So split ingestion and transformation to use the enhanced compute engine. When would you do this?
So when you first start using Dataflows, you may be tempted to create one single data flow that includes all ingestion and transformation logic. This may reach the memory limits established. So our recommendation is that you split your ingestion and transformation logic into two separate data flows so you can use the enhanced compute engine that has been released for Power BI Premium users. The reason is that it only works against linked or computed entities.
And so if you have Premium but have not yet turned over the compute engine switch on, do you still recommend this practice?
Yes, this practice is going to help you at least simplify the debugging and diagnosis of the refresh issues you might be facing.
Okay, so something closely related to this, and hopefully this works. Perform actions that can use the enhanced compute engine.
So the recommendation here is that you first apply those joins and filters that can use query folding in the SQL engine before applying the rest of the transformation, so you can just apply them on the subset of the data.
Okay, and so is there any specific reasons why you highlighted joins and filters here?
Yes, because these types of transformations are more expensive.
Okay, so this is, you're hating on SharePoint here. Split data flows when connecting to SharePoint. What do you mean by this?
So by design, SharePoint limits the amount of requests sent to get data. So if you're connecting to multiple files on SharePoint, you might be facing those limits. So the recommendation here is that you see that you're failing those limits, you should split your data flows to connect to multiple files and set the refresh schedule apart.
And so, like, if I'm working with lots of files, like, how did you end up splitting your data flows?
So on our case, we were working with a very large file and several small files. So the large file we separate on one single data flow and create another data flow for the other two files and just separate the refresh schedule by 30 minutes apart.
And is 30 minutes the recommendation here, or?
I would say that you could start by 30 minutes, and if you're still facing those limits, you can just change the refresh schedule.
That sounds great. OK, so something on a slightly different topic. So avoid scaling refresh for linked entities inside the same workspace. What do you mean by this?
So dependent data flows are locked while the source data flow is being refreshed. So for example, you have the 3 source data flows that are going to be refreshed at a schedule. Once they're being refreshed, the following data flow, the global sales, is going to be locked. And when the source data flows are finished refreshing, they're going to trigger the refresh on the global sales. So if you click next, we would see that this is what we don't recommend, and the recommendation is the following. Because each time one of the source data flows is going to be refreshed, it's going to automatically trigger the global sales data flow to be refreshed as well.
So we actually see a lot of customers not realize that this happens inside data flows. And so if we go for an example here of the stores data flow, so imagine it kicks off at 9 o'clock and it finishes at 9:30. Global sales is locked while the refresh is taking place. And then after it's finished, global sales will then refresh, and then global sales is then locked again. How do you avoid this locking behavior?
So if you want to just avoid this behavior, you must separate the data flows into separate workspaces. Have your source data flows on one workspace and the global sales on another workspace.
And then something closely related, you go to recommendation here, create a separate workspace for ingestion and transformation.
This best practice is talking about the permissions you have on the data. So the recommendation is that you have a separate workspace where you have the ingestion, where you have the raw data, and have only a few users get access to the raw data, and have the other workspace where you have the linked data flow, where you can make transformations but limit the persons that have access to the raw data.
So in typical organizations, normally the person that has access to the data sources is very highly privileged. They'll want to bring in the data and have access to that data, but they don't want anyone else to have access to that raw data. They probably want to transform it, and then once they get into the final workspace, then they'll give access to that workspace. Is that?
Yeah, so you have that one source of truth in your organization.
OK, so this is a bit of an odd one. Ensure capacity is in the same region.
So as of today, Power BI Dataflows does not support multi-geolocation, so you must ensure that your premium capacity and Power BI tenant are created in the same region.
And what about for ADLS Gen 2?
ADLS Gen 2 is still in preview, but if you wish to use that feature, you must be sure that you have it in the same region as well, because it's going to be blocked if it's not in the same region.
And part of the reason why we block it is to avoid egress costs, so you don't have the Azure cost for every time data is transferred from one data center to the other. This is a cool one that I see a lot of customers make. Separate on-premise sources from cloud sources in data flows.
So the recommendation is that you split your data flows by data source type. Why? Because it helps you avoid the internal limits on memory, and it also helps you simplify the diagnosis of the refresh issues you might be facing. So it's easier to know if I get an error on my SharePoint data flow or my SQL and know exactly where I'm facing the issue.
And is the recommendation here you create a separate data flow per gateway or separate data flow per data source?
Per data source, so you know exactly where you're facing that limit.
Awesome. And then separate data flows into a separate capacity.
So if you still feel that you're facing these issues on memory limits, we have two options. You can either scale up your premium capacity or change the way that you have your capacities and move your data sets to one capacity that you don't want it to have the same resources as when you're refreshing your data flows.
And I suppose it's important to note here that with data flows and especially data sets, they both contend for the same set of resources. They both are memory-hungry resources. And so the recommendation that I'll add here is in data sets, separating out data sets and data flows sometimes is a good idea, but sometimes putting like the AI workload and reporting services on the same one as data flows, because they don't contend for necessarily the same resources, it's actually good to kind of create one capacity for non-important things and a separate capacity for mission-critical things like your data sets. And so after all these best practices, Delia, did it make a difference?
Yes. So for that specific case that I worked on, we were having to connect to an on-prem source, a cloud source, and different files on SharePoint. So actually using these recommendations help us understand where we're facing the issues, and we're able to give the solution.
Awesome. Thank you so much.
Thank you.
So I'm going to go to the customer feedback session, and I'm going to go through some features that we haven't yet released, but will hopefully handle some of the most common pain points that you have with data flows. And so I might name and shame some people. Well, so I get a lot of feedback from Twitter. A lot of people send me direct tweets about data flows, about how they don't like something aspects of data flows. So if David is here, please raise your hand. I don't think he is actually here today, so I'm glad he isn't. He actually sent me these 2 tweets, and he said he wants his time back. He doesn't like the fact that when you save a data flow, you are made to wait for tens of minutes just trying for the data flow to validate. And so he sent me these tweets. I then said, hey, I like your idea. Hold on. We will have you covered. And so I'm going to show you a new feature that we haven't released yet on data flows. So I'm just going to come out of the presentation, and I'm going to show you what we've done here. So I'm in Power BI. I'm in a development environment for Power BI, and I'm just going to quickly create a new data flow. And I'm going to show you something really cool, if my internet connection works. So I'm just going to hopefully wait for Power Query to load the list of connectors. Maybe today. And I'm just going to quickly create a blank table, and I'm just going to put the word hello here. So if you notice what happened before is if I click next and I click save, I'll be made to wait in the validation pane. That no longer happens anymore. So if I click save and close, notice there's no validation screen anymore. Now, when I give it a name, I'm going to click test data flow. I can now commit my changes without having to make everything valid. And now what Power BI will now do, it will actually now run through the validation immediately after, and will then validate and then put a tick once it's validated that data flow is successful. So now we've deferred the validation. We do it afterwards. We know this is a common pain point. This feature should be available very soon. And as you can see, it's just set a tick box there so you can actually see that it's actually correctly validated. OK, so this wasn't the only issue that we had. Let's go through some more. So so Alex sent this tweet 6 months ago, and Amir Nets then sent me an email saying, hey, Mo, what are we doing here? And so just to describe the issue is, Alex had a data set that he had over, like, I don't know, 20+ queries. And to convert his data set into a data flow, he had to copy each one by one. So he went in, right-clicked in Advanced Editor inside Power Query Desktop, and then pasted it inside data flows one by one. And he really said to me, he said in the email, can I have my time back? And that's a recurring theme that I see with data flows. Can I have my time back? And so, Alex, we have you covered. There is another feature that you guys will love. And so I'll quickly go back to my data flow, and I'll show you something else cool. So it will not be designed exactly like this. This is a preview feature. But as you notice, when I click on the Add button there, I've got this new option called Copy Queries from Dataset. I wonder what this does. And I'm going to click this, and I can see all the data sets in the service. We will hopefully support uploading a PBI file as well, just in case your data set isn't in the service yet. But I'm just going to select this nice, cool-looking forecasting sales volume from Yassine, from one of the team members, and just click Next. And within a second, I've now converted that data set into a data flow. And in this case, he had 21 queries in his data set. And the great benefit here is I just need to type in the credentials, and I'll be able to then work with them. So the reason why it's got all the warnings is I haven't put in credentials. So once I put in the credentials, I've now successfully converted a data set easily into a data flow without much effort. No longer do I have to spend hours and hours and hours to just do that. And that feature will be releasing hopefully very soon. I'm going to estimate around January or February, depending on how much the team wants to work over Christmas. So I'll move back, and I'll go through the final one. And this feature actually has released, so this won't be so surprising. So Dataflows user got in touch with me 10 hours ago, and he said, can you please help me move one data flow from one workspace to another? And if you guys use the APIs today for Power BI, you'll notice that it is actually possible to do this. So you can actually use the API to export the data flow definition file, and then import the data flow definition file using Power BI. However, you may have noticed that there's no documentation on telling you how to do this, and also the API has problems. So we have you covered. So we had an intern over the summer work on this cool feature called the import data flow feature. So I'm just going to head back over there, and I'll show you how this works. I'm just going to click cancel out of here. And I'm just going to go to a workspace that I have access to earlier, and I'm going to click on a data flow called the forecasting data flow. And what I'm going to do is I'm going to say export.json. So you're probably wondering, why would you ever move a data from one workspace to another? So one of the common scenarios is I have dev test, and I want to migrate one data flow from dev to production or to the next environment. Or in my case, is sometimes you set up a POC, and you then want to move, like you set it up in a specific workspace, and that's not the one that you actually want to set it up in. You actually want to move it to the actual one that's managed by IT. Today, the way you'd have to do this is you actually copy and paste it. And it's that same time as, can I have my time back? So I just saved, I'm just going to click here, save as. I'm just going to save it on Bogdan's desktop here. And then what I'm going to do is I'm going to say new data flow. And you guys may have realized that there's a new box that just showed up a couple of weeks ago called the import model. And what import model allows you to do is you just basically point it at that file that you just saved. And so I'm just going to go and find that file. Let me see where I saved it. I called it forecasting1, and nothing happened. Let me try that again. If this doesn't work, well, we have a problem. Maybe we have a problem. Let me try this again. Let me try a different environment. So all you had to do was go to new data flow. I'm going to click import model again. If this doesn't work, maybe it's my crappy computer, or Bogdan's computer, I should say. And yeah, I'm going to blame Bogdan's computer for this. It actually is in production, this feature today, so it's actually really released. I presume it's because I'm on a demo environment for Power BI, so I'm not on a production environment for Power BI, because the other features were not there. Maybe we've broken this feature as part of the other features. It's great. We're always pushing the boundaries here. I'll move on to the roadmap slide, and I want to spend a couple of minutes here so that you guys get a feeling of where we're heading with the product. And so I'll start off with December. So I'm going to read this off because we've got so many features coming. So we're going to hopefully in December release DirectQuery support for data flows. So that was a feature that effectively which Christian demoed. You will be able to eventually do DirectQuery on top of data flows, which will save you the time of having to create a data set. And will also save the time of actually trying to bring in all the data into a data set onto your local desktop environment when you could just query the data source directly. The improved validation flow, I got it here as a December-ish. I'm hoping that the new flow that I showed you at the start, where you can actually save time by not having to wait for validation, we're hoping to release around the December timeframe. Moving into January, we're hoping to finally GA the ADLS Gen 2 integration. And that will come with a host of features like supporting take ownership, which we don't support today, and supporting a range of other features and enhancements which I'll cover. We will also support certified data flows. So you guys can then certify your data flows so that you know which ones are IT approved, which ones are the central source of the truth. And so you can easily work with your data flow just like you do with your data sets. Moving into February and March, we're going to release many new capabilities for ADLS Gen 2, including creating multiple ADLS Gen 2s to your tenant, attaching multiple to a capacity, or allowing you to, within a tenant, attach one to one capacity and another one to another capacity, and even do that at a workspace level as well. So we really want to help you get into Azure Data Lake Gen 2 so you can actually make use of your data with other Azure services. I also got here that the copy queries feature that I just showed earlier will also be coming around that time frame. We're also going to be supporting the government cloud. So if you are in the, today Dataflows is not supported in GCC, the data center for Azure. We're actually going to be supporting that around the February-March timeframe. We're also going to support something called workspace level refresh, which we didn't actually do a demo today. I'll explain what that means. So the problem that Delia described earlier, where you have dependent data flows, you don't actually want to refresh the same data flow 3 times if you have 3 dependencies on a single data flow. What you actually want to do is just say, can I schedule this whole workspace to refresh at 9 o'clock in the morning? Can you figure out the dependency chain, and can you then refresh them? And so we're going to go and support that. And as a result of that, we will also support refreshing the underlying data sets that are dependent on the data flows. So you don't have to guess or play roulette with the refresh times to make sure that the refresh times happens to coincide with after the data flow has refreshed. Moving on to around the April timeframe, we're going to be releasing a brand new feature that we haven't shown today, and I would say that we probably just started engineering on it like last week, is data quality alerting. So I'm not sure if you guys get the pain, but I have a lot of data flows, and when data flows has some bad data inside it, I don't want some management chain to tell me that there's a problem. I like to know about it beforehand and then give them the response. And the data quality alerting is effectively that feature. So I can then set up and say, hey, if there's missing values in the data, if there's some values going over the threshold that I don't necessarily like, can you please alert me? We'll also integrate this with Power Automate, not Flow. Power Automate, so that if you want to then trigger off an email and send it to a group of users or maybe to a specific IT security group, you can do that. Create a support case in CRM. You can go and do that as well. And we'll also support that kind of integration and make it seamless. And we're also going to support, hopefully DirectQuery, we'll put GA for DirectQuery. And we'll also support giving you individual entity level status inside data flows. So you can actually see how many records does each table in a data flow have, and how much size it takes on disk, so you can exactly see what's happening with your data flows. And then April plus, Christian said we're not committing to any timelines, and I second that thought. We are going to support, basically it's called trickle updates, what Christian showed earlier, where we have the real-time updates, effectively real-time writes into data flows. That's going to be called trickle updates. We actually have a team in Microsoft that might be using this feature soon, and so we are hoping to make that available for you guys as well so you can leverage it. And so I'll go back to the first slide that I showed earlier, and I'll leave an email address that if you have any questions, you can reach out to us directly. Hopefully, you guys will understand the main benefits of Power BI data flows, and hopefully you got a good, deep understanding of the architecture. Feel free to reach out to us. We're always happy to have feedback. If you don't want to reach out to me directly and want to tweet it, please feel free. And then hopefully next time, you guys will make the next session, and I'll go through your tweets next time. With that being said, thank you to the awesome speakers that joined me today, and thank you everyone for joining.